Alrighty, AFDA students, welcome to our video lesson number 4 here. And as you can see from our title, we're going to be talking about literal equations and formulas. And we want to be able to solve these literal equations, hard to say, and show our work. We're going to be solving for a specified variable when we're all done. Now, some things that we're going to look at here or use today is the property of equality, and you know about that. That's what I do to one side, I do the other side type thing. The math that we're going to be doing is undoing some things. So if you want to undo addition, you're going to have to use subtraction. Let me change this pen here. Going to have to use subtraction. If you're going to undo subtraction, you're going to use addition. If you have division, you're going to use multiplication. And if you have multiplication, you're going to use division. So those are the math operations that we're going to use today. Is this basically adding, subtracting, multiplying, dividing. Now the first example I have for you is dealing with something called torque. Now these letters are a little hard to see, but torque is equal to the force, that's an F, times the lever arm. So you have a force, maybe you have a wrench here if you've ever seen those in the tool chest or something, and you have a bolt that you're trying to tighten up. Torque is sort of what you do to tighten that up. Now, question I have for you in example 1 is, can we solve the equation for the F or the force? So I'm going to write this differently. If we have torque is equal to the force times the lever arm, can we solve it for that F? Can we get that F by itself? Well, the L is multiplying with the F, so we're going to go back up here and use one of our tricks, and we're just going to come in here and divide both sides by L. Again, using that property of equality, and we have that the force is going to equal to the torque, that's that big T, divided by that lever arm. So down here, this is something that actually exists out there. There's things called torque wrenches, and there's pictures of a couple of those right there. They have different styles where you hand read it. They have LED readers, they have meters, they have all kinds of stuff for those torque wrenches. So they might use that to tighten up the bolts on your tire. Now, let's see some more of this here, what we're going to utilize. So let's check out some more examples here real quick. Is that last week you saw stuff that looked like this. You saw x minus 2 is equal to 5. And last week all you did is had to add 2 to both sides, and you wound up with x is equal to 7. Well, this week, or for this lesson, you might see something like this, like x minus y is equal to z. Crazy stuff. Not a real formula here, but we can still solve this for the x. So if we're looking for that, we know we got to get rid of this minus y, and going back up top, the way we undo that is just to add y. And what we do to one side, we do to the other side. So we wind up with x is equal to z plus y. Pretty basic. So again, same sort of technique is ringing true here for us. Let's look over on the other side. Again, this is last week what we did. If you had 4a is equal to negative 16, you would just divide both sides by 4, and you would have a is equal to negative 4. This week, if we have something like ha, is equal to negative w, we got to solve for a. We just got to get rid of that h there. That h is multiplying, so once again, the way we undo that is to divide by that. Some of y'all think about that canceling out, but we get a is equal to negative w divided by h for that answer. Now, this was a two-stepper, if you remember from last week. The way we'd solve that is we'd go ahead and subtract 3 from both sides, and we get 2x is equal to negative 8. Then we divide both sides by 2, and we get x is equal to a negative 4. Now, once again, you can check these equations here. These literal equations, or formulas, if you will, those you really can't check, not unless you toss some numbers in there. So we can plug that in, run our check step, and we're in good shape. This guy here is a two-stepper. Let's see what's going on. It says solve for x. So we notice that the x is right there. It has the a beside it that's multiplying and the b that's adding. So we're just going to go ahead and subtract b from both sides. and we get AX is equal to C minus B. We're still looking for X, so we got to get rid of that A that's multiplying, so we divide both sides by A. So we get X is equal to C minus B all divided by A. Squeezing that in there. Okay? Now, last week we had like a fraction in front of a coefficient. Well, the way we got rid of it is multiplying by its reciprocal, which is instead of 1/3, we're going 3 over 1. We're going to multiply both sides by 3 over 1. That's the same thing as 3. So we get B is equal to 4 times 3, which is 12. Now we have a fraction out in front of these two variables, all equal to that big A right there. We're solving for B. Let's knock out that fraction first. We're going to multiply by 2 over 1 on both sides. So we have BH is equal to, A times 2 is just 2A. Now we're looking for B, so we have that H that's multiplying with it, so we're going to undo that by dividing by H. I'm going to scoot this over here a little bit so you can see it. So we get B is equal to 2A divided by H. That's a 2. Now, let's slide this down and look at maybe a real formula that you're familiar with a little bit. So let's slide that down a little. Lights just went out on us, so we'll fix that. So, clear this out real quick. Try to. All right, here we go. Everything went out. It says, given the following formula from Miss Didlake's science class, F equals 9/5 C plus 32. Now, you might remember that formula from degrees Fahrenheit, and the C stands for degrees Celsius. What this problem wants us to do is solve for the C. So we're going to use the same technique that you just saw. In other words, we're going to look for that C right there. So we've got to get rid of the 9/5 that's multiplying and dividing with the C and the 32 that's adding. So we're going to use the same playbook that we used last week and subtract 32 from both sides. We're going to get F minus 32 is equal to 9/5 C. Now we still want C by itself, so we got to get rid of that 9/5. And what we learned last week is we can multiply by its reciprocal. So I'm going to change pens here and multiply both sides by the reciprocal of 9/5, which is 5/9. Multiplying both sides there. So these go away right here, so we get C is equal to, let's say, 5/9 times F minus 32. So that might look familiar to you from a formula that you had for degrees Celsius. I'm going to write it over here. I'm going to use the symmetric property and change sides. Maybe that'll look better for you. If I write it this way, put the C on the left side, the 5/9, and the F minus 32 right here. Okay, squeeze that in your notes there for you. Now, it says if F equals 86 degrees, find the degrees in Celsius. So since we solved for that, this is why people might use these formulas, is that they may go ahead and rearrange them so they can use them. So we're going to put an 86 right in there for the F. We would subtract 32 from that, and then we multiply it with 5/9. I think if you did that, you'd wind up with 30 for your answer. So if you plug that in your calculator, I think it's going to be 30. Now, on the home stretch here, going over these real quick, here's some real formulas, or close to real formulas that exist out there. If we're going to solve this P equals IRT for T, we would just divide both sides by IR. I'm doing 2 at a time right here. So we get T is equal to P divided by IR. Fix that R a little bit. Right here, let me change pens. If we're solving this for B, which is right there in your notes, we'd have to get rid of that 2 that's dividing. You remember that trick with the fraction bar? We're going to multiply both sides by that. So we'd get 2v is equal to b L H. We're looking for b, so we got to get rid of the L and H that are multiplying with it. So we're going to divide by the L and H. We can do 2 at a time there. So we get b is equal to 2v divided by LH. Last but not least, we have 2x minus 3y is equal to 15. It says solve for y right there in parentheses. So that's what we're looking for, is that guy there. So we'll get rid of this 2x. That's a positive 2x. It's really adding by subtracting 2x from both sides. We get a negative 3y equals 15 minus 2x. And then we can divide everything by negative 3. And we get y is equal to negative 5 plus, because that's a negative divided by a negative, 2/3 x. Now I might rewrite that this way. I'm going to use the commutative property and write y is equal to 2/3 x minus 5. So, as you notice, we're using the same tricks that we've been using. We're just applying it to formulas or equations that have more than one variable in there, but same playbook we're using. Thanks for watching.